any more tests this semester?
Okay, we gave you guys 7 minutes to go through your notes. Hopefully that was enough time to kind of review what we talked about last week, Thursday. Again, we're just going to be discussing fuel storage, fuel delivery systems. Just a quick little reminder as we go through this, our review, because again, I want to make sure that everyone's kind of remembering and on board with what we talked about last week. And to be fair, I kind of forgot where we left off in this particular class. Standards, yep. Let's see here. Parts, a lot of parts on this one. It looks a lot of confusion in terms of how things are linked together, but we're going to systematically go through this. Let's see, we have a return type fuel system in comparison to a return-less type fuel system. Yeah. Remember, a return system allows the fuel to return back to the fuel tank, where a returnless system is a one-way trip. For that indication. Also, that looks like an earbud.
Yeah, buddy.
Let's see here. What else we got here? Fuel system problems. Again, leaks are a very common issue that we need to be mindful of, because fuel that's leaking out of our storage tank or along the fuel rail has the ability of combusting when we don't want it to, and that can obviously be detrimental to the vehicle and our health. So we want to make sure that we are catching any leaks and repairing those as quickly as possible. But it's not the only issue that we potentially have. We could have also lean or rich air fuel conditions, right? We talked about the stoichiometric curve momentarily in regards to what rich and lean actually means.
Rich AF.
Yeah, that's air fuel mixture.
I'm rich AF.
Okay. And then we were getting into the two different, I guess you would say, areas of our fuel system. We have a fuel delivery, fuel storage, if you will, and a fuel injection. All right? Does this all seem familiar still? Yes? Now, we did talk about drivability problems. Fuel does go bad. Okay, gasoline is refined and processed. There's various different cleaning agents and additives that are given to gasoline in order for emissions and the health of your engine. Okay, as we burn this fuel, we want to make sure that it is combusted completely as possible to extract the energy to be able to go down the road. All right, now there's also additives and whatnot given to fuel, so then that way, Chris, this can be stored for as long as possible, but over time it will break down. Okay, and again, I want to just emphasize that it's not going to break down to like water. It's still going to ignite, but unfortunately, it just will not ignite in a way that we can utilize inside an internal combustion engine. Okay, so if you still have bad gas, you can still throw it on a fire and it will still burn. Okay, but it won't ignite the way we need to. So there's a whole science behind this part of the vehicle, and it's very, I guess you would call it high level chemistry.
What's the difference between gas and kerosene?
How it's refined, like the molecular structure.
What is
if you will.
gas? Is this gas come from like the oil?
Yes, crude oil.
Where does kerosene come from?
Crude oil.
Where does propane come from?
That's natural gas.
That's an air gas then.
Okay. Now, both liquid and vaporized fuel pose a safety problem. Again, I want to remind you on this, liquid gasoline, not going to burn. Okay? It's the atomization or the vaporization of that gasoline into the air. We're going to be burning the vapor. Okay? So, we obviously, when we're storing our gas, we store it as a liquid, because that's what it would be at in room temperature. But then we have to, as we transport it up to our fuel rail and our fuel injectors, we have to figure out a way to get it from liquid to vapor. Okay, and again, there's a science behind how we do that. But on a hot summer day, as your vehicle's sitting out on a blacktop, right, Mason? That's going to heat up the gas tank. That liquid gasoline is going to naturally evaporate, just like water would. Okay, so now we go from a liquid storage to a vaporized inside my gas tank. We don't want that to obviously leak out. but we also don't want that to come into contact with any kind of ignition point, whether that's a spark or energy source of some sort. Okay? So if it is leaking out, again, that is a cause for concern. And typically speaking, you're going to be able to smell that. All right, you're going to say, hey, it smells like gasoline. Why is that? Well, there's a leak. There's no other explanation for that. So now we have to figure out, okay, where is the leak at? It's very difficult because you can't see the gas vapor that's coming out. Okay? So, regardless of when you are working on our fuel system, whether it's the fuel tank or the delivery system or the injectors, we want to relieve the fuel pressure ahead of time, so that way, as I'm going to take things apart, a whole bunch of pressurized gasoline doesn't shoot out in my face and get on my clothing. Because again, if I get that on me, it is an ignition point that I could start on fire, or some equipment could start on fire. Okay? So we can take preventative measures by bringing a fire extinguisher that's rated to deal with that stuff ahead of time, so if an accident does occur, all my safety precaution measures are right there, ready to go. Okay?
With safety glasses or just a safety squint?
You're going to always want safety glasses. Okay? But again, we want to depressurize our system. The easiest, quickest method to depressurize that is really simple. You find your fuel pump electrical relay, you pull that out of your fuse panel, so that way when you go to start the car, your fuel pump is not energized, which means that the fuel pump is not pushing fuel forward, okay? And all the fuel that was in the fuel rail and fuel injectors and whatnot is being consumed by the engine, and eventually it's going to starve. Oh, it ran out of gas. The engine's not going to run for very long. As soon as it dies out, you know that you have no more fuel available in the front and no additional fuel was pumped forward. Okay? At that point in time, you can go in and check the fuel pressure just to verify that that's true. Usually a gauge that's on the fuel rail itself. Okay? You plug that in, should read 0. Awesome, I am now able to safely remove any type of component on the fuel system, do my repair, do my testing, and then obviously once I do that, I verify that it's fixed, and then I can move on. Okay. Now fuel tanks specifically have a vapor dome at the top and a non-vented cap to prevent escape of fuel vapors. Fuel tanks are designed to be able to withstand this pressurization of the gas that's turning to vapor. Okay, so we don't have leaks. And it does that a few things. Obviously, we have a dome for that to take that into account. But even all of our ways to mitigate these issues, we're still going to have some vaporization, right? You're not always going to have a full tank of gas. As you're driving, you're going to consume it. It's going to get lower and lower and lower. Okay? Now, what we want to do is we want to depressurize that fuel tank so then that way it's not like a balloon that's being blown up, because by doing that, eventually, if we have a leak or we have a concern of a leak, that pressurization is going to find the weakest point in that and it's going to escape. So what we need to do is we need to create a system that allows for the depressurization of the fuel tank without allowing the vapor of the gasoline to escape, because that is a pollutant. All right, so we got some engineering issues here that we need to address. Now, fuel tanks in general for modern day vehicles are typically made out of polyethylene plastic. Okay, we want them to be as lightweight as possible. Polyethylene plastic is easy to form, it's durable, and it can withstand the chemical reaction over a lifespan with being in contact with the gasoline. Okay. Previously, you'd have steel or aluminum metal that was used to house the gasoline. Okay. I would say if you might still have an aluminum gasoline tank. Again, we want it to be as lightweight as possible, because the lighter the weight, the less the engine has to work to overcome that, the better fuel mileage you potentially could have. Okay. Steel is probably not typically used too much often anymore. Okay.
Doesn't it rust too?
It can, yes. Now, obviously, in order to form rust, you need to contact air with the metal. But usually, when you've got gasoline touching
What
that,
kind is bacon?
hopefully you don't have condensation inside your gas tank.
You stupid.
Hopefully you don't.
But like,
I'm
no,
not
the
saying
one-
it's not
the one-
possible. Okay. Now,
But there's no-
how gasoline tanks are designed is that you have something called a baffle or a surge plate inside the tank itself. So it's not just a big round empty tub that when you fill it up, fills up. Because as you are driving, right, the road might be rough, you might be on gravel, you could be on uneven ground. We don't want that gasoline to be sloshing back and forth.
Why?
Okay? Well, think about this, right? Let's say I have not enough gas in my tank. Okay, I'm almost on empty. All right? Hey, I'm going to go drive to the gas station to be able to fill up my tank. As I'm driving, I'm going 55 miles an hour, and now all of a sudden I'm going around a corner. Physics demand that that gasoline is going to move off to one side of the gas tank as you are cornering, right? For every action, there's an equal and opposite reaction.
Sure.
Okay? What if my fuel pump is on one end of the gas tank and all the gasoline now is moving off to the side because of how I'm turning? Now all of a sudden that's trying to suck up the gasoline, and because you were empty or close to empty, that's moved off. Now all of a sudden I'm starting my engine for gas, I stall the car. Okay? So the idea is if I have baffles, basically like walls inside my fuel tank, it still allows for the gas to move back and forth, but it prevents that shifting that's going to dramatically be happening as I'm driving. Now as I'm making that corner, the gas can't move all the way to the end. Okay, so now I don't starve my engine. Okay, so that's what the purpose of a baffle.
Those are in
Okay,
big trucker
or
tanks.
surge plates. Say that again?
They were in big trucker tanks.
Yes, yes, it's the same principle, right?
Yeah.
If I've got a 18-wheeler and I'm hauling milk, let's say, I don't want that liquid to be sloshing back and forth, so I have baffles inside that. Okay. A fuel filler neck also contains an anti-surge restrictor used to prevent spills. All right, so as you put your fuel filler in there, right, at the gas station, you're pumping it up. Okay, we obviously don't want the gas to kind of vomit out of the filler neck. So we're going to have anti-surge restrictors to prevent those spills.
Yeah, can you stand outside and watch your gas tank? Watch your gas fill up?
Yeah, I do now. I was at a gas station just actually a couple weeks ago. I was filling my gas tank, and you know how normally it like fills up and then it automatically shuts off? That was broken on my handle, and gas was starting to pour out. Thankfully, I was right there watching it and able to stop, so I didn't spill much. But I had to go in and notify the attendant that gas handle was broken. So I don't know if they fixed it or not. Anyways, you can see here the baffles, right, are basically these walls. These baffles still have holes in it because we still do want the gasoline to fill up equally across all the areas of the tank. We're just trying to prevent the sloshing from back and forth. Okay, you guys got your Plickers cards that I handed up to you the other day. Or at least you should, because I told you to put it inside of your notebook. I'm going to bust this out. Alright, which of the following are placed inside fuel tanks to prevent fuel splashing? Oh yeah, this works really good. I like it.
I don't want to have to dig for it every time.
Well, anytime we're taking notes, you should be able to get it out.
Oh,
Can I just do something?
Uh-oh, I don't.
You get me?
I got you.
Wait, that's the next one. Just put it in.
I got you. I got you. Good, we good? 5-4. Chris? No, bad Chris.
He called me a bitch boy.
Hi. You and Easton should be sitting back there.
Huh?
You big mustard.
Yo,
Are you not hearing this?
I
wasn't here today, right?
Are you not hearing me? Both of you should be sitting back there. Am I wrong? So let's move.
No, you're guessing.
I'm actually here for a reason because I can't see back there.
You only need to hear my beautiful voice. If you can't see, then you should be right here.
Move up there. Get you, Johnny. Alright.
There we go. Easton?
Over here today, man.
It was perfectly fine until Chris came.
No. I wasn't even talking to him. He's talking about.
Sorry.
I'm a bitch boy.
Stop with the language. Thank you. Easton?
Yeah. Oh, it's like.
Be respectful.
Thank you.
Hey, Johnny.
I can't hear you.
Bro, now I can't see because it's big boy.
I'm so sorry.
Bro, move, bro. Don't even sit there.
Oh, is that going to sit over there too?
Oh.
Alright, which of the following are placed
Up
inside
right
fuel
here.
tanks to prevent fuel splashing? The easy answer is
See.
C, baffles.
Yeah.
Right? We just got done talking about that. So obviously you were paying attention. That's good. Okay. Okay, getting more into our fuel tank. We have a liquid vapor separator that prevents liquid fuel from reaching the vapor storage canister. Okay, so again, this is all part of our depressurizing our fuel tank. So, part of this engineering is designed to allow the, I guess you would say, fuel tank, as fuel vapor is becoming gas, or excuse me, going from liquid to a gas. What we want to do is we want to prevent the liquid gas from actually getting in, reaching our vapor storage canister. Because if liquid gasoline got in there, it can damage that part. Okay, because the vapor storage canister will not function if it's wet. Okay, so we want to just separate that out. Especially if we're talking about like the vehicle moving and rocking back and forth. All right, the fuel tank sending unit. Now, we talked briefly about this last week, but the fuel sending unit is an all-in-one component that contains multiple various different components in our fuel storage and delivery system, and it's all kind of placed inside the fuel tank. Okay? So in this case, I'm going to get my marker out. We've got our pickup tube. Again, think back to our lubrication system. We've got our oil pan, which is the reservoir for the oil tank. Think of it as like the gas tank. All the oil lives in there. We have a little tube that goes down like a straw. So as the oil pump is basically sucking up that oil from the bottom, we want it on the lowest part. Same thing here. The pickup tube is going to go basically all the way down here at the bottom as it's going to go up. Okay, so it is literally sucking up from the bottom of that fuel tank. So that way, even if you are running on very low gas in the tank, it's still just going to be able to hopefully pick that up and utilize it. Okay. We also have a float operated gauge sender. On your dash you have a gauge to tell you how much gasoline or fuel you have remaining. Okay. So how does that gauge know how full or empty your tank is? Well, I've got this float right here that literally floats on the top of the gasoline in the tank. Okay, think of it like a bobber if you've ever gone fishing, right? Hey, I'm going to go throw that out there. The bobber sits on top of the water, moves around, the hook's underneath that. Oh, the fish grabbed it. As the fish is moving down, it pulls the bobber under the water. That's how you know you have something. Now you can set the hook and reel in the fish. Okay? It's nothing too crazy. Same concept here. This float is like the bobber. So if my gas tank has this much fuel in it, right? I'm going to be able to know because this is going to move up or down based off of that level. And as this moves up and down, this component here rotates depending on how much or little that is. And then this basically sends a signal to the computer saying, hey, this is the angle at which my arm is at. The computer's program saying, hey, that angle or degree, it equals, this percentage of fuel left. and it translates that to our gauge. Okay, pretty simple on that regard. All right. We also have a fuel strainer or a filter sock. Again, this is a pre-filter before it actually gets to the filter. So again, I've got my strainer, my fuel socks down here with my pickup tube. So if there is any large debris that is in my fuel tank, whether that's rust particles or gum or sugar or whatever that may end up being, it's a pre-filter before it pulls that gasoline up to go through the fuel pump, because I don't want to damage my fuel pump. Same concept with my lubrication system, in that I've got a screen on my pickup tube, so any large debris in my oil doesn't get picked up before it gets to the oil pump, because again, the oil is not filtered when it goes through the oil pump. Okay? And then finally we've got our fuel pump, which is going to be an electric motor that lives inside the sending unit that again is used to pick up and send this out to the front. Okay? And it's kind of fun to think about because the fuel pump is an electric motor, right? And it lives inside the fuel tank. Why doesn't it start a fire? That's something I'm just going to pose right to you now. We'll answer that question later. All right, if you have an older gasoline tank and it's contaminated, maybe it's rusty, maybe it's just got bad gasoline in it, the best option for you to do in terms of service on one of these tanks is just to simply replace it. Don't try to go in and repair it or restore it. Just not worth it. And more likely than not, you are not going to make an adequate repair to it. Okay? So just buy a new one or go to a junkyard and find one that's in better condition. But more often than not, your fuel tank is actually going to be easier just to buy a new one, replace it.
What junkyard can you go to and you can take stuff? Not take stuff, but like get stuff.
Most junkyards.
Just go in the junkyard and
Yeah.
buy what you want.
Pretty much. But you gotta pick it. You gotta take it off and do all that sort of stuff.
How much does it cost to go to a junkyard? Like, don't you have to pay for like?
You have to pay for the parts and stuff. Maybe depending on the junkyard, you might have a fee to go in.
That's what I was
But
thinking.
most junkyards around here, I would assume that you could just
You
go
have to
in,
pay by the pound.
grab something, and
Yeah.
yeah.
That's
All right,
nice, bro.
fuel filler caps. Fuel filler caps are very similar to our radiator caps. All right, so obviously we'll want to pressurize our radiator cap for a reason, because if we pressurize our coolant, it raises the boiling point up. Awesome. That allows me to take more heat away from my engine. Fuel filler caps are going to be able to pressurize my fuel storage system, or more importantly, prevent those fuel vapors from escaping. Okay, so it's going to seal things off. And as the pressure raises, and this thing in the center here can move up and down as a relief valve, so that way it can actually move that pressurized fuel vapor to our storage, or vapor storage canister. Okay. So this is actually quite technical in regards to what it does. Most people just thought it was a cap, like a milk jug. You just tie it on, it's good to go. But there's a lot of engineering that goes into this for very specific purposes. Okay. Also, you fuel filler cap, after you get done putting gasoline in it, you want to keep tightening it until it starts clicking. Okay. There is a specific torque that it's trying to measure in order to achieve the clamping force to seal up that fuel tank so we don't get leaks. Okay? And it'll say right on there, tighten until it starts clicking. That clicking noise is kind of like the same idea as a torque wrench when it clicks. Okay? Can't over tighten these, but you have to go to the point where you are clicking it. More often than not, if your dash lights up with a light and it says, hey, you have an evap system leak, aka your gas tank is leaking vapor, right? We can't hold any pressurization in there. 90% of the time, 95% of the time, it's a bad gas cap. I can't tell you how many times people have, like, we've scanned people's cars. Oh, hey, your gasoline tank is leaking. go buy a new gas cap. Right? $5-6. They buy a new gas cap, they put it on, fixes the problem. Okay? Most leaks in your gas tank is due to bad gas cap.
Will the code clear itself after that?
Yes, it should. It should. Okay. Now, in the event that you have a code for a gasoline gas tank leak, you replace the gas tank filler cap, and that code doesn't go away, now you gotta go in and figure out where that leak potentially is at. I'll tell you the second most common. So again, like 95% of the time it's this being faulty. The other 5% of the time, or 4.98% of the time, it's gonna be your evap canister. Alright, caps are often tethered to the vehicle so that way you don't lose them, and are designed to prevent over tightening, again, right? Clicking and whatnot. It is illegal to drive without a gas cap, and thankfully Fond du Lac County doesn't have to do this, but if you live in like Sheboygan County or towards Milwaukee, they have to do emissions testing. Okay, you actually have to bring your vehicle to a specific spot, and they have to go through and verify that your vehicle is not actively polluting the environment. One of the things they're checking is the condition of your gas cap. Okay, does it seal? Does it hold pressure? And if it doesn't, they'll actually not verify you until you get that fixed. And again, it's super cheap, $5-6 typically.
What if you drive like a diesel truck?
Yeah, still gotta.
No, like with rolling coal at those places.
Yeah, no, it's not environmentally
My grandparents.
legal. Okay.
It's fun though.
It is way fun. Black smoke coming out of your tailpipe. Oh boy. I know. Every time that a vehicle does that on the highway, I'm just tickled pink with impressiveness. I'm like, man, that person clearly has a PhD, makes way more money than I do, and I envy that person.
My grandparents had trucks like that when my mom was still a kid, and they used to. My mom said they used to do that all the time.
Oh yeah. It's gotten a lot better, obviously, with newer diesels because there's been emission standards that have been implemented by law.
And you can still cut them off.
Yep, illegally, but you can. All right, a loose gas cap can cause an evap system malfunction and illuminate the mill. Okay, we just talked about this. It can set off a check engine light. Oh man, what's going on? And you think worst case scenario, you hook up to the computer and you realize, oh, it's just an evap code leak. Mr. Nagetsky said that's a loose gas cap most of the time. More often than not, it might not even be a bad gas cap. It just might be that it's loose. You just got to go in and turn it a quarter of a turn and make sure it clicks, and that takes care of it. I mean, as weird as that is, these things are amazingly sensitive. Okay? I think it's supposed to detect a hole that's about like a pin size or less. So if you got a pinhole size leak in your gas tank, it'll set off the mill. Okay. Now again, let's go ahead and get into this. So again, I'm putting gasoline into my gas tank right here. It goes through the filler neck. It goes into my tank. Here's my float, so I know what my level of my gas is at. Down here at the bottom is my little pickup tube, my filler sock. So gas goes in here and goes up and out to my delivery system. In the summer, okay, when it's hot outside, this liquid gasoline is going to start to turn into vapor. And it's literally going to start blowing up my fuel tank like a balloon. Again, we need to relieve that pressure somehow without allowing the gas vapor to escape. So how do we do that? Well, we have a little valve basically that's in here that's going to open up. Once we have a sensor, the fuel tank pressure sensor is sensing, hey, I've got an excess amount of pressure. That tells the computer, open this valve. It allows those gas vapors and that pressure to push those vapors up and into a vapor canister. That vapor canister has a bunch of active charcoal. All right, it's a filtration method. All that active charcoal does is grab a hold of that fuel vapor. So we're literally filtering the fuel vapor. So this starts filling up with fuel vapor. all of the filtered air is then basically vented outside into the environment with no hydrocarbons, no gasoline vapor. So that's how we depressurize it. As soon as the computer recognizes that this vapor canister is full, right? Hey, my charcoal filter can't hold anymore. It then activates a purge solenoid, and all that active carbon releases those fuel vapors, and we send it through our engine and burn it. So then that way, it doesn't get out into the environment as hydrocarbon. Does that make sense? I mean, it's not an overly complicated process, but it's kind of a neat engineering hack, if you will, that allows us to maintain adequate fuel pressure levels in our tank while still allowing the depressurization and holding onto that hydrocarbon. Okay? All right. Enhanced evap systems have a fuel tank pressure sensor used to determine if the system has evaporative leaks by monitoring fuel tank pressure. And again, it's very sensitive. Okay? It's not going to wait 4,000 years before notifying you of a leak. Very, very small leak will cause this thing to trigger. Okay? Now, also on a side note, if you have a little light and saying, hey, you got an evap leak, again, 95% of the time, it's your gas tank filler cap. Just check that to make sure it's tight. If it is, buy a new one. Put that on. Again, super cheap fix. Could be that canister could also be leaking at that point, right? Or it could be a faulty fuel pressure tank sensor.
Or there's a evap sensor in your engine bay.
Or your gas tank itself has a leak, which is not very common. Okay? Not very common at all. It's mostly one of these smaller components that are regulating the actual tank pressure itself that's gone bad. All right, some vehicles don't even have a fuel filler cap. Okay, I know some Fords have this spring-loaded flapper valve that's really designed to remove the human component of sealing up that tank after you put gasoline in.
So easy though.
Okay, right? So when you open up your gas tank, you see this thing right here. Uh-oh.
Yeah, my mom's smart about that.
Okay? Doesn't even have a gas tank. All you got to do is you put in your fuel filler points there from the gas station, squeeze the trigger, this little flap right here, spring loaded, opens up, gives way. Awesome. Once you're done, you pull it out. This thing closes back up, seals that off, no leaks. Okay? It does come with a little potential tube here that if you do have to fill up from a jerry can, you're going to have to insert that into the flapper valve to keep it open so you can pour in gas from a jerry can. Yeah.
You can also, you get an evap code for your purge.
Yes.
Your purge system.
Yes. That's the
I learned
canister.
that.
Good stuff. All right, how are we doing? Oh, we got 3 minutes.
We're good.
Yeah, I think we're going to end here for today. We'll pick up on 18 tomorrow. So anyways, real quick review of what we talked about today. First and foremost, final exam study information is now posted in Google Classroom. You have a week to go through that, get that information. There's a total of 53 questions on that particular document. Only 40 of them, choosing at random, will be on the final exam. I gave you a 3x5 note card. That can be used front and back however you want in order to prepare for that test. Please make sure you are bringing that 3x5 note card to the final exam if you intend to use it.
Are the test answers in order?